Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to learn about the second part of this subtopic called problem solving. As for stoichiometric calculations, there will be 6 hours tutorial altogether. As for problem solving in stoichiometry, you need to make sure that you use balanced chemical equations or redox equations, depends on which equations the questions have given you. For instance, we are given hydrogen gas to react with fluorine gas to give you 2 hydrogen fluoride. This is already balanced by using inspection method. So we have 2H in here and 2F in here, altogether 2HF. Stoichiometry tells you that both reactants and products are relying on one another. Even though you have only information regarding product, you can find information about the reactant as well. So from this example, we could now interpret that 1 mole of hydrogen gas react with 1 mole of F2, or instead of using react, you may also use 1 mole H2 needs 1 mole F2, or 1 mole of H2 require 1 mole of F2. They are all the same. Other than that, we can also say 1 mole of H2 produces 2 mole of HF, and the other one gonna be 1 mole of F2 produces 2 mole of HF. To see this more clearly, let's bring the number into the battle. First, you need to classify the informations into theoretical. Theoretical is the given value. They are fixed because they comes from a theory of balancing. So this number comes from these chemical equations. We term them as theoretical value or the given value. And then the experimental value, the needed value, they vary according to the experiment. So for this example, this statement says exactly the same thing as in chemical reactions. So how do we know this? Reactions of hydrogen gas. So here we got hydrogen gas, here we got hydrogen gas as well. And fluorine gas, we have F2, and F2 produces hydrogen fluoride. We got HF. How many moles of HF are produced when 5 mole of F2 are consumed? So there is a slight difference in here in terms of amount of F2, which is 5 mole, and they are looking for the amount of HF. Our unknown in this case gonna be the experimental value of HF. Everything else is already there. So how do you do this? You're gonna make the theoretical value as a reference, which we're gonna rely most on them, and write the stoichiometric relationship between F2 and also HF at the first line. Why F2 and HF? Why not H2 and F2 or H2 and HF? We got so many relationships just now. Well, though there are so many relationships can be interpreted from the chemical reactions, we're going to focus only on the species that has value, because no point of doing something that won't give us any outcome. So focus on the species with value only. So you're given value in here, additional value, means we want to focus only on the F2 together with the amount of moles that we want to find for HF. Theoretical value will always be your lifesaver to do this stoichiometry, but don't forget to balance it before using it. So we already balanced it before, so that's why we can simply take the number and put it into the first line. As for the second line, we're going to write our experimental value of 5 mole F2. So 5 mole F2 produces unknown mole of HF. In here, you can put an unknown if you like before calculations, or you can already show your cross multiplications and get the final answer. So how do we get these? It's basically 5 mole F2 times with 2 mole HF, and then divide by 1 mole F2 to get your unknown here. It is not necessary to show these calculations because what matters is the final mole you got from this relationship. Please remember that stoichiometry relationship between reactants and products can only be done by comparing mole. If you have mass or volume, you must first convert it to mole in order for you to do this stoichiometric relationship. Another way to write this relationship is by using this triple horizontal bar symbol. This symbol represents all those needed, required, or produced earlier. But make sure to draw this bar, not just dot. Make sure they have this horizontal bar, not dot, dot, or dot. You will be penalized if they don't look like one, since we know that the relationship is simply cross-multiply everything, so lastly, you will end up with 10 mole as well. For any chemical reactions, apart from knowing we have reactants on the left and products on the right, we also need to know the type of reactants. We have limiting and excess reactant. Limiting reactant is the reactant that is completely consumed in the reactions and limit the amounts of products formed. So in other words, these reactants will be used out first in the reactions and they're going to determine the amount of products formed. Here we're going to relate chemistry to cooking. Let's say you want to bake your breakfast, egg sandwich. You're going to need a slice of bread and an egg. We can write the recipe for this kind of like chemical equations. 1 slice of bread plus 1 egg, put it together, they become your egg sandwich. The ingredients we start with, we can think it as reactants, and the product, egg sandwich, is what we end up with. You often start with different amount of ingredients. This happens a lot in cooking, same goes to chemical reactions. Your reactants usually have different amount to start with. At the moment, we are talking about limiting reactant. Limiting reactant comes to the play when we ask the questions, given this different number of ingredients, what is the greatest number of egg sandwich that we can make? As you can see, we got 7 slices of bread and only 5 eggs. We can really only make 5 egg sandwich. If these were chemical reactions, we'd say this egg is a limiting reactant while the bread is the excess reactant. There are 2 ways to determine limiting reactant. First, by comparing a reactant and a product. Reactant that produces fewer amount of products are going to be the limiting reactants. Or you can also compare a reactant and a reactant, and for this comparison, its conclusions is a bit different from the reactant product comparison. The reactant is considered limited if amount needed that you're going to get from the stoichiometric calculations is more than the amount provided stated in the questions. So you really need to carefully identify the type of amount they belongs to. Well, I'll show you an example for both methods. We're going to use exactly the same reactions. You are given these informations. First, identify who's going to be the theoretical, who's going to be the experimental. The one that comes from the balanced chemical equations will be the theoretical, while the one that comes from the statement or initial amount is experimental. The questions ask for mole of product in experiments. In order for you to get this amount of mole, you need to first check which of these 2 reactants gonna be the limiting reactants, because limiting reactants state that they're gonna determine the amount of product formed. We'll try the first method, reactant to product. You're going to compare each reactant with the product. So let's start with 1 mole of H2 produces 2 mole of H2. So from the initial amount given here, we have 3 mole of H2, therefore they will produce an unknown amount of HF. So how are we going to do this? By doing the cross multiplications, 3 times 2 divided by 1, and you will get 6 mole HF. While for the second equations, we're gonna have 1 mole of F2 produces 2 mole HF. Given in here, 2 mole of F2 produces 4 mole of HF. Once we've done the cross multiplications. This method requires you to look for the smallest mole of product formed to be eligible to become the limiting reactant. We could see mole of product formed by F2 is less than that of H2 because here we have 4 and here we have 6. So we have to make a reason like since F2 produces fewer mole of HF, 4 and then 6, before jumping to conclusions of limiting reactant gonna be the F2 while excess reactant gonna be the H2. Next, we're gonna use another way by comparing reactant and reactant. Comparing differently will also lead you to different term use. Theoretical is always needed as it will be the backbone of this relationship, but please focus on the other two terms I'm gonna show you. When comparing reactant and reactant, you only need to show one stoichiometry relationship. In previous method, we have two. We're going to first write the theoretical value 1 mole H2 require 1 mole F2. You can use needs, react, or maybe you can use the triple horizontal bar. They are the same. Again, for the second line, same relationship applied, but please change your term a bit here. Instead of experimental, use provided. It is basically the same as experimental, but it is much easier to change it for comparison purposes afterward. You could see we have both amount already. What is left to find then? For this method, we only keep one species to rely on. I prefer you to keep the one on the left, which in this case the 3 mole H2. But keeping only 3 mole H2 means we are going to have a totally new mole of F2. So by comparing 3 mole H2 produces, so we got unknown F2 mole in here, then we are going to get 3 mole F2 by doing the cross multiplications. So the value you have F2 here, we need to term it as needed. Next, we're going to take both provided and needed value of F2 to compare with. Don't mix up with H2. We use H2 just now only for reference, but the main highlight now is the F2, both needed and also provided here. Provided here means how much do we actually have to provide for the reactions to occur. Needed here means how much is actually needed for the reactions to occur. So, for reactions to occur, the amount of provided should be higher than the amount needed, or else these reactions will immediately stop. Since the number of mole F2 needed is 3 mole and it is higher than provided, which is 2, means the reactions will stop once all the 2 mole has been used up. Therefore, we could say that F2, which will limit the productions of hydrogen fluoride, is the limiting reactant, while H2 is the excess reactant. So you need to make a statement like this, give some reasoning. Why do you say that this is going to be the limiting reactant? Then only you can come to a conclusion that this limiting reactant is the F2 while excess reactant is the H2. If we have found the needed amount of F2, do we need to do the same for H2? No need. You just need to choose only one species to compare the value, because eventually both of them, if you, let's say you take this number and make it as reference and get the needed value for H2 and then you compare with the provided value, they will give you exactly the same answer of limiting reactant F2 and excess reactant H2. As a conclusions for limiting reactant, you don't need to do both methods in the questions. If the questions already ask for amount of product, then you can straight away doing the reactant product method. If the questions don't ask for product, you can also use this reactant product method. Same goes to this reactant method. Choose only one that you find the most convenient. Mentioned earlier that reactant method has only one stoichiometry relationship, while reactant product has 2 stoichiometry relationship to be done. This is not always be the case. Just now, we only cater for determining the limiting reactant, but in real questions, you'll further be asked about the amount of products or reactants being formed. or being used. If we gather both methods we have done and aim to find the mole of product, so if you could see, so we first use this reactant product to get the number mole for the product 6 and 4, then only we can get the conclusion that the 4 mole of HF is formed for the product, because the question asks for the product of the mole of product, sorry. And then as for reactant, if you choose to use reactant method because you find it is practically less working than the reactant product, if you can see here, then you are wrong. Because even after knowing the limiting reactant, let's say we make a conclusion here that the F2 is the limiting reactant, you got to do another stoichiometry showing how much product will be formed. Okay? Here you could see you need another stoichiometry, so a total of 2 stoichiometric relationships as well. And lastly, you're going to get the full mole of HF formed. So both methods will give you exactly the same answer but different sequence. The stoichiometric relationship might give us the information regarding the theory. But as a chemist that deals with real-life experiment, we also need to consider percentage yield or purity of samples calculations to measure the efficiency of the reactions. As for percentage yield, we have actual yield divided by theoretical yield times with 100%. So the yield must be in gram or mil only, the amount that we can actually see. Another formula that could be used is purity of samples, where we have mass of pure substance, the one actually undergo the reactions, divided by the mass of impure sample, the one that hasn't undergone the reactions yet, and then we need to times it with 100%. So make sure you have this mass or maybe volume, the one that can be seen. So theoretical yield is basically the amount of product predicted by the balance equations when all the limiting reactant has reacted. In reality, chemical processes actually never reach the theoretical yield. So possible reason could be that the reactions wasn't given enough time to complete, or if the process involve transferring between containers or filtration processes, then obviously you could lose some product in those transfer process. So there's a lot of reasons why we could never get that 100% yield. So you know, the theoretical, sometimes they already give you like this. It all depends on the questions itself. How do they ask you? What kind of statement they have made? And then for actual yield is the amount of product actually obtained from a reaction. Sometimes it will be given in the questions like, what is the percentage yield if 3.5 gram of HF are produced? We already produced the 3.5 gram of HF. That means that is your actual yield. That is your pure substance, in other words. Let's try this one example that's going to apply all we have learned in this video. What is the percent yield if the reactions of 25 gram P4, the first species, with 91.5 gram Cl2, the second species, produces 104 gram PCl3? So this is the product. So what should be done first? Always take out the chemical reaction. So we have P4, Cl2 and PCl3. Before we proceed with anything, make sure to balance the equations first if they are still unbalanced. We got just chemical equations, then let's do the inspection method. Start with the monoatom, the P. On the left we have 4P, on the right we got only 1P, so we need to times it with 4. When multiply 4 with P, you're gonna affect the number of Cl as well. So 4 times 3, it should be 12 chlorine on the right, and it should also 12 chlorine on the left. But at the moment, you only have chlorine exists as diatomic molecule. So instead of putting 12, you need to divide it by 2 first. So then you can put the balance equations as in P4 plus 6Cl2 plus 4PCl3. Next, extract all the informations given. Informations given here belongs to an experiment, in other words, the actual value. The keyword here is percent yield. means product, so we have to focus on the amount of product. So you're given here the actual yield, means you need to find the theoretical yield. To find the amount of product, we need to rely on the reactants as well. We need to first determine which reactant will limit the productions of the products. It's either P4 or Cl2. We don't even know yet. To do this, we need to do the stoichiometric relationship, which can only be done with the number of mole. So at the moment you are given mass, then you need to change it to mole first. So as for the mole of each reactants, we'll start with P4. P with 31 gram per mole as the molar mass, so times with 4 you'll get 124 gram per mole, divide with the 25, you're going to get 0.2016 mole. As for Cl2, each Cl2 got 35.5 gram per mole as the molar mass, times with 2, you're going to divide 91.5 with 71. It will give you 1.2887 mole for Cl2. Can we already take the smallest number of P4 as the limiting reactant? No, we need to apply the method we have learned in previous page, where you're going to choose reactant or reactant product. It's all up to you, but since the question is already asked for product, then let's just go for reactant product comparison. Make sure to do comparison for both reactants and look for the smallest mole of products formed. Since 1 mole P4 produces 4 mole PCl3, and then we'll take this number here, 0.2016 mole P4 will produce how much mole of PCl3. So we're gonna do the cross multiplications, and lastly we're gonna get a new mole of PCl3, 0.8064 mole PCl3. This is when P4 becomes a limiting reactant. This is the amount of PCl3 being formed. Then for Cl2, we know that 6 mole Cl2 produces 4 mole PCl3, comes from the theoretical value here, the chemical equation, the balance equations here, and then simply take this number 1.2887 mole we are relying on, and then do the cross multiplications to get the unknown here. So the amount here will be the mole formed when Cl2 become the limiting reactant. So we could see we have a bigger number in Cl2 than PCl3. So what does this mean? Since P4 produces fewer mole of PCl3 than Cl2, then P4 gonna be the limiting reactant. Once we have found the limiting reactant as well as the mole of the product, then we can simply find the mass of theoretical yield by multiplying it with molar mass of PCl3, where P has 31 gram per mole and then Cl has 35.5 gram per mole each, then you get 137.5. And lastly, your theoretical yield gonna be 110.88 gram. Don't forget the unit gram because this is the mass. Last but not least, don't forget to substitute all the informations into the formula by first write the general equations. Make sure that your theoretical yield is bigger than the actual yield. Then our percent yield for this reaction is gonna be 93.8%. So you are now qualified to attempt the remaining tutorial questions for this chapter, as you have done everything with this subtopic. Yay! Congratulations! We have completed chapter 1 matter, but before we put an end to this chapter, let's quickly see what we have learned so far. In the first subtopic, you have learned about isotopic notations for both neutral atom and also ionic charge. And then we learned about 3 types of abundances or intensity. They are percentage abundance, decimal point abundance, and also ratio abundance. And then from the abundances, you get to calculate the average atomic mass and also relative atomic mass. The only difference between this average and also relative mass is one got unit, one got no unit, because they already relate it to the 1/12 of the carbon 12 mass. Okay, for 1.2 mole concept, you learn about chemical formula. So there are two chemical formula to be learned. One is empirical formula, the simplest version, and then the molecular formula is the actual number of elements present in your compound. Then the concentrations measurement. In high school, you only learn about concentrations, mole per liter, but here you've got a number of concentration measurements. There are 5 altogether, the new one. You have molarity, percentage by mass, percentage by volume, and also the mole fractions. So you really need to know how to define these definitions so that it is easier for you to do the calculations. And then as for dilutions, you know that in all chemical process, you somehow will start with a very concentrated solutions, and then in order for you to do the reactions, you need to dilute it a bit. You need to apply the formula of M1V1 equal to M2V2, where 1 usually from the concentrated solution or the stock solutions, and the second one is the one that is diluted. As for the last subtopic that we have learned, we learned about balancing equations. So look here, we have S at the end of equations, means there are two types of equations you learned. So there are two methods as well to balance the equations. One is inspection method, another one is ion electron method. And then as for stoichiometrical calculations, you know that you need to first find the number of mole if you're not given the number of mole, and then you need to do the stoichiometric relationship. You have two types of method to find the limiting reactant before proceed to find the amount of products or reactants they want. So you need to make sure that you know all the terms being used for each method. And lastly is the percentage yield or the purifications of sample. You simply need to substitute everything you have found in the previous part of this 1.3 stoichiometry and then simply substitute into the formula, then you'll get your final answer. Once the chapter is completed, you should go attempt the past year questions that soon will be given in Google Classroom to get crystal clear idea of how the real examinations questions will look like. See ya, Assalamualaikum.